Hello and welcome to this online talk for the 18th IGEL conference. Thanks for having a look at this video. My name is Tilmatine and I am a PhD candidate within the ELIT network, affiliated with the Free University of Berlin and the Radboud University in the Netherlands. My work focuses on the neurocognitive processes underlying the act of literary reading, and more specifically on the reading of narrative poetry. Right here you can see a devil convincing an old academic of the beauty of a young lady, which is a pivotal scene from Johann Wolfgang von Goethe's Faust, the literary work that we are using as stimulus material for a number of studies that I'm currently involved in. But more on that later. Today I'm going to present you a pre-study on this stimulus material, a sort of sanity check, if you will, when we, that is my academic advisors Jana Lütke and Arthur Jacobs, and me, when we compared computationally calculated text properties with detailed rating data for our stimulus material. So that's evidence from text-driven rating analysis. So, neurocognitive literary reading processes. What does it even mean? Well, literary reading is a complex and multi-layered psychological process. Not only is text reading in general already multi-layered and complex, literary reading on top of that also asks the reader to get involved with aesthetic fancy language as well as to mentally create a fictional world when a just as fictional narrative takes place. The processes underlying literary reading are only indirectly measurable. We can see someone read a text and we can ask the person what they thought about it afterwards. We can even put them into an fMRI machine or measuring their heart rate while they're reading. But none of these observations can necessarily be classified as direct responses to the text, at least not without us creating a model for how these internal processes relate to the indirect observations that we can make. Luckily, there are enough models for that. This, for example, is what I currently use as inspiration. A combination of the NCPM, the PIA model, and the so-called model of failed foregrounding. Please don't pay too much mind to all of the little boxes right now. The important takeaway here is that very different sorts of mental states can lead to very similar sorts of measurable observations. There's one very important advantage of written language as a stimulus, and that is permanency. Written texts are discrete and non-changing as a signal, and all the information used by the reader thus remains available in that exact form in the text. The stimulus material and can be studied in that exact state that the reader found it in as well. To put it differently, all reading is a sort of text analysis, albeit maybe rather implicit or maybe even dilettantish one. And the text analysis can be simulated, at least to a degree, and perhaps very differently, but still. Automatized sentiment analysis tools like Sentiart and the new and wonderful Glean are able to quantify the emotional and aesthetic potential of texts. That is, they use huge corpora of literary texts that are and a set of well-selected, emotionally loaded words to create vector space models, which provide us with numerical values for basically every word in a dictionary. Numerical values that represent the proximity of any given word to a certain emotion. Here, for example, we have a very small fraction of a Sentiart table, providing us with calculated emotional values for a number of words that are, as I see now, mostly related to cars. Well, in my personal experience, Germans tend to have very strong emotions about cars in general. And here you can see Autobahnschild, so a highway traffic sign, tends to occur in semantic contexts that make people rather angry, but not exactly fearful. Be that as it may, you can look up this value for each content word in a semantically useful unit of language, like a sentence in a text, a stanza in a poem, or even an entire chapter in a novel. Average it, and you get set emotional potential that's available for the reader if they can and want to use it. The quote-unquote ideal reader uses all of that potential. Next to that emotional potential, there's also a more superficial factor to account for. A lack of textual comprehensibility can be an obstacle for some readers, and is also quantifiable through measures like the expected familiarity of the word, that is the frequency, the general frequency in a corpus, or the sentence structure. Much like with an emotional potential, you can also create a sort of readability or comprehensibility potential of a given piece of text with these measures. And that is exactly what we did for our stimulus material. Johann Wolfgang von Goethe's Faust, finished in 1808, is a grandiose work in German that combines the three classic disciplines of literature in the European tradition, namely drama, it's a play, epic storytelling, it's a long and intricate narrative, and poetry. It rhymes and makes use of lots of stylistic devices. As the aforementioned NCPM, the New Cognitive Poetics model of literary reading, states predictions for both aesthetic and immersive aspects of literary processing, having stimulus material that incorporates both aesthetic poetry and an immersive narrative is of course ideal for us. Thus we selected 4 excerpts out of it for a number of studies on the neocognitive processes of narrative poetry reading. These excerpts included a total of 140 stanzas of roughly the same length. They can be summarized to 26 narrative events or scenes of rather differing lengths. Some of these scenes are rather moody, as the scene we talked about in the beginning, with the grumpy old academic being desperate with his studies and being tempted by diabolical carnal desire, or cynically merry, like here, where the same grumpy old academic can change into a younger man to exploit the naivete of a young Christian maiden. The stanzas in this text were rated 1-for-1 by human participants on valence, arousal, comprehensibility, and liking. All stanzas were then also computationally analyzed to identify around 20 text features on the stanza level. Let's take a look at the comparison between our computationally calculated values that we got from the text and the rating of actual human subjects for each stanza. Computational values are depicted in blue, and in red you see the data we got from human beings made out of red flesh and blood. On the level of text excerpts, this is not exactly meaningful. Sure, the averages between the computational and the rating data are rather similar, but there are no differences at all between the excuse me. Yeah, between the excerpts. These are the text excerpts. Even worse, the variance in the computational data is much higher. It engulfs the entirety of the variance in the subjective data and makes this whole comparison even less meaningful. But of course, that is not the best look at the data that we have. Lots of variance within the text excerpt is unnecessarily averaged out, which makes the entire narrative structure invisible. After all, because this is a pre-study, where there was no problem to interrupt the subject's reading flow all the time, we have ratings for each stanza. So let's take a look at these data. Here we have again in blue the computational estimates of the valence in each of the stanzas in order of the narrative. And the same thing for the average rating of the human subjects per stanza in red. All of it being standardized to the same scale for visibility. Immediately we can see that this is much more expressive. There are heights and low points that appear both in the textual computations and the subjective ratings. And if the average reader and the computer both agree that these high and low points are at roughly the same place within the text, then we can argue that this curve here indicates a certain narrative structure, a purely data-based narrative structure that we as researchers can even see without knowing the content of the text itself, although of course we do know it. These curves are smoothing splines, created based on the data by the statistical program JMP, by the way, so it's worth mentioning that they're a mathematical construct almost, with all of the potential issues that entails. And the colored areas here that indicate the competence of fit are not always perfectly transparent in their formulas either, but the averages that it's all based on, these tiny dots here, they're very real, of course. Now, if you take those two curves and correlate them with each other, we get a significant but not amazing predictive effect of the computational data for the ratings, with a correlation of around 0.3 that explains some 10% of the total variance. While this is a lot better than the differences between the excerpts as a whole, it is not simply a matter of zooming in as much as possible to get the better predictive values. No, let's instead zoom out a bit to the next best unit of narrative relevance. Zoom out from the poetic units that are the stanzas and take a look at the narrative scenes that have been identified by literary scholars. So, multiple stanzas are part of one scene. And yes, this looks a lot better, even though we have less granularity. We have very visually clear parallel development of the narrative curves here, and with a correlation of about 0.5, the computational values explain an entire quarter of the variance. This implies that the emotional valence in narrative poetry, both as measured by computational values and by subjective ratings, this emotional valence is not merely influenced by the use of pretty words, but also by the context of the larger narrative. At least this seems to be the case for the average ideal reader. So it might be very different for individuals who do not feel immersed in the story, for example, but more on that later. So this is what we have with emotional valence. Now let's take a look at the next variable, emotional arousal. Here we see an even stronger predictive value with a correlation of 0.5, excuse me once again, explaining a quarter of the variance even on the stanza level. Perhaps arousal, that is excitement, is just a little easier to calculate through single powerful words than a more ambiguous construct like valence or the goodness of something. But previous findings never indicated anything to that end, to my knowledge at least, so this might just be an oddity of the specific data set. In any case, arousal too, as the computational values perform even better in predicting the ratings on the level of narrative scenes compared to the stanzas that we saw before, with a correlation of almost 0.6, explaining a whopping 30% of the variance. We're lucky that IGEL specifically provides us with values for emotional valence and arousal, but what about the more complicated aspects of mental states during reading? This conference concerns itself with inclusion and diversity. The classical elitist problem of any language use is really, but even more so really with any language use, but even more so in literary writing, is the comprehensibility of a message. And there are many aspects that flow into a reader's comprehension of a text, many of which based on individual differences, and again, more on that later. But any given text itself also has its own inherent comprehensibility. And this is, of course, quantifiable. The theoretical knowledge that we have says that not only one singular text descriptor should predict comprehensibility. There are common singular readability indices like the one with flesh, but they're usually applied to entire texts and not stanzas, and they're just not highly relevant for poetry in the first place. So what I did was that I just took a number of text features that are theoretically known to be to some extent relevant for comprehensibility, and then run and compare a few k-fold neural network analysis on our data to find out their importance as predictors. Then I combined the ones with the main effect above 1, so 0.1, to a new descriptor for comprehensibility. You can see the formula here. In this case, with these specific weights for these specific text features, but of course this is machine learning, so your results may widely differ from this, and my results next time as well. This newly created descriptor performs very well in predicting the comprehensibility ratings, explaining 70% of the variance with a correlation of 0.8, but it's also not entirely surprising as it was constructed exactly to predict the specific set of ratings, right? This is still a very good simulation of the average reader and can be very useful for some purposes, but it's not always perfectly viable like that in experimental settings, because it does to some extent need the reader data that is trying to simulate. On the scene level, once again, the descriptor performs even better as a predictor for the rating data, with a correlation close to 0.9, an explained variance percentage of almost 80%. This does surprise me a little, to be honest, because I would have expected for comprehensibility to be a factor that affects the reader on a very low level, talking about complicated sentences and infrequent work. But on a second thought, it also seems plausible that narrative context just enhances the understanding of a stanza, or respectively clouds it. If the reader doesn't understand the entire narrative, then the chance might be higher that they also don't understand the specific stanzas happening, or whatever the stanza is describing. Just like with comprehension, a reader liking a specific stanza is also not a mental state that we can just link to a specific singular text feature. Naturally, emotion plays a big role. It's one of the main rewards we get out of experiencing narratives, according to most theories at least. But liking is also known to be dependent on both comprehensibility and on aesthetic factors. There's an interesting mix because aesthetic beauty in literature has a very interesting relationship with comprehensibility in the first place. They can enhance each other and also obstruct one another, but that is a question to investigate at another moment. In any case, I tried to combine all of these elements again in a number of neural networks analysis, and got a new descriptor that looks like this for now. Note that it has our comprehensibility descriptor and Senti-Art's AAP in it, both text features that are already combinations, so we're getting a bit abstract here. Sadly, this also shows in the stanza level comparison with a correlation of 0.314 and a mere 10% of explained variance. On the scene level, things get even worse, surprisingly. Possibly liking a stanza is just more disconnected from the narrative, or liking is just too broad of a category. We're currently looking into finding a way to have narrative elements be considered just as much as stanza level elements. For example, by asking about the sympathy with certain characters. That's nothing new. Lots of empathy studies do that as well. But of course, this also has little to do with this narrative structure that we're looking at. Anyway, liking is a measure of personal preferences. Thus, we may also just finally have reached the point where it only makes sense to continue if we finally take individual differences into consideration. In the subject, variance is higher for liking and comprehensibility. We can see this very well here, this box plot. Valence and arousal have a lower variance than liking and comprehensibility. And this fits well with previous evidence for individual differences playing a larger role for these constructs. And it also honestly just makes intuitive sense. Unfortunately, our number of participants was not high enough to say more about interactions of individual reader properties with liking and comprehension. Largely this is because of the current uncertainty to get participants, with the laboratories closing down every winter and the general unpredictability of the pandemic situation. So we had to and will have to continue to concentrate on other aspects for now. Getting back to the average-based analysis, here we have an overview of the narrative structure as predicted by the 4 types of ratings we had: comprehensibility, valence, arousal, and liking. Now it may be time to let this literary scholars talk again and point out for us here where some important narrative events take place. For example, these 3. Spoiler alert, we've got the interrupted suicide attempt of Faust. You can see everything become a bit less pleasant up to this low point. Then everything lightening up a bit once he hears a children's choir sing some Easter songs, convincing him not to commit suicide over academic desperation after all. Then we've got what I like to call the Merry Garden Talks, where 2 looming couples discuss love and relationships in rather mundane language. You see comprehensibility being rather high here, with our main character behaving pretty slimy, and the deceitful sex conspiracy, when our sympathetic main character makes a young girl put her mother to sleep just so they can spend the night together, possibly poisoning the mother. If we take the general tendencies for each of the rating means in these important points of the narrative, the interrupted suicide attempt, the Merry Garden Talks, and the deceitful sex conspiracy, and we do that for each of the ratings, either going up or going down or staying neutral, then we can directly compare this qualitative assessment with the quantitative computational data we get from our textual analysis. Here in red, you see the differences to the rating data, so where our computational trends differ from the rating data. This is neither perfectly exact in our assessments here of going up and going down. This is really just done for the presentation now. Nor is it a perfect prediction. You see differences here, especially for likability, which is, as we said before, difficult. But it does indicate that the narrative structure is reflected in these mostly word-based text features. A narrative structure that is also recognized by the average reader, as we saw on the slide before. So, if we regard the text features as either identical or very close to the cues that readers use to understand, to get involved with the text, it does make sense that text features, if chosen correctly, predict mean ratings along a narrative structure. Text features can thus model the average, if not ideal, reader's narrative perception. This graph here compares the valence ratings of a single subject, one person, with the corresponding Gini values for computational values for each scene and except one. These are the scenes. In blue are predictions, and this is the single subject. Clearly the subject is not an ideal reader, but they're very, very close to it. Wherever they deviate significantly, which might be here for example, I didn't check it, we may want to look for reasons. That is, individual deviations from calculated potential can be considered areas of interest. And thus it would be interesting to explore individual reasons for reading non-normality right here at these areas. Reading non-normality being anything that's different from the ideal or average reader. Just for future research. In conclusion, if ratings reflect the cognitive processes while reading and text features can predict ratings for the average reader, then the same should be true for other less invasive measures of neurocognitive processes related to reading, like reading behavior, eye tracking, as done by us already. I will present the results of that in a conference soon. Or neuroactivity, which might happen very soon as well. Individual differences can be related to deviations of text feature predictions on the narrative level for any given individual difference that makes sense, or even on an individual level once we're so far. At this moment, I unfortunately am not, because of the pandemic situation, but you never know what the future brings. And these are some exciting prospects that I'm looking forward to, and I hope that I could make you understand a bit better what this all is about. Thanks very much for listening, and we'll see each other virtually at the actual conference where I can answer some questions.